Hey everyone, ATI here. I thought I'd do something different today. Kind of how all my videos work. Everything's different anyway. But today, gonna be kind of dipping into the world of what I do for a career. I am in telecom, if you haven't realized yet, and we do a lot of, or I do a lot of. Originally, was designing and engineering.
Hey, look, buddy. I'm an engineer.
I was originally started off as a tower climber. And I did that for about 3 years. And then after that, I was a engineer, a cell site engineer. We would gather documentation and information on site, and we would design and implement a blueprint and develop a plan on how to upgrade a cell site. What we needed to do, what teams we needed to put in play, what equipment we needed, and basically just get the crews out the door and make sure they had everything they had to build the site and build it correctly and to the customer standards and whatnot. We did this for all the big carriers, AT&T, Verizon, T-Mobile, and at the time we also had Sprint. That was an older project. And it's been a fun industry. It's been really, really cool. I'm changing a little bit of the path though. I'm actually going from the telecom mobility RF side to the central office side.
Outstanding.
So we're going to be starting to do a lot of router installs and a lot of heavy fiber installs, which is something I've been wanting to mess around with for a little while. So this is my opportunity to do it. I'm going to take it and run, and hopefully it's really cool. But anyways, in the video you're about to see, it's not much of a how-to or how a cell site works. It's just more of a what's in a cell site, what you see if you're looking at the cell site at a distance, and what's in the shelters. A lot of the stuff here is from 2020, so it's a little older. We don't have those big boxes in the shelters anymore. We still have the power plant and the DC systems and the batteries, but as far as those big boxes and cabinets you see, we don't have a lot of equipment inside taking up room anymore, producing a lot of heat. A lot of the radios and the transmitters are located up on the tower. And I also wanted to say before we get into the video that don't try this at home. The cell sites can be very dangerous places, and there are a lot of laws in place to protect the cell site landlords and cell site carriers. The cell sites are 911 system capable, which means they are FCC backed, and if someone is caught tampering or is found to have tampered with a cell site in an unauthorized way, you will be facing federal charges. I think they might even go up to a lifetime sentence. I don't know. But you would be tampering with a preservation of life system, and that is not something you want to be messed with. These sites are alarmed. They are monitored. They are monitored from the door, HVAC, power, everything. So even if you open that door up for a second, somebody's going to be, and you're not signed in, somebody's going to be coming up to the site wondering what you're doing. Let alone the tower, the landlord for the tower also has a procedure for signing in and making sure that you are authorized and you're completely have all your certifications in place. So uh, getting through that, like I said, this is just an old video, and I'm going to be posting it here just to do a brief description of what it looks like on a cell site, if any of y'all are curious. If any of y'all want a more detailed video as far as the actual physical operation of a cell site and the more technical aspect, I don't mind doing one. There's a lot of different lingo in there, so I feel like we might be better off with a live stream, but that's up to y'all. If you want to comment on anything, go ahead. If there's any RF engineers on here, you're going to be annoyed right off the bat that I keep calling a 3G cabinet a CDMA cabinet. I don't believe it's a CDMA cabinet. I think it's more of a GSM cabinet. but it is what handles the 3G. And additionally, in the video, I say the 3G is only for voice and the 4G is for data. That's not true. The 3G can carry voice and data as just as good as the 4G can. The only difference is the 4G has a much bigger bandwidth to do so and is capable of seeing higher speeds. 4G speeds were industry rated for 399 megabits as their max, and the 3G speeds I want to say were maybe 20 to 50 megabits at max. So that's some correction in the video you're about to see. But yeah, again, just if you got any questions or you want to do some corrections for my terminologies, and I didn't cover something in this little pre-briefing video, put it in the comments. I would appreciate it, and let's get to it.
So this is a guide tower. It's about 400 feet, roughly. On that top part is Verizon. Pretty simple. And then on that bottom part is AT&T. A little bit more equipment running up there. But today we're going to be looking specifically at Verizon, which is that shelter. And the shelter is where all the equipment is kept to power the site and provide the power to the antennas. In this case it's wattage and in regards to transmit and receive power. So once again, this is Verizon. Their coax cables running up the tower, and then over there's AT&T. But do my best to explain everything that's going on from this perspective. But you'll notice these wires coming out, and then they got some electrical tape right there. These are grounding units. So on the outer jacket of this, and if you peel back this black rubber layer, you'll actually see a copper jacket, and the copper jacket is for shielding. And then they have these things called ground kits, which are what these are. And you'll notice this little bulge. There's actually like a little, I want to say, a little spanner in there, and it kind of just slides onto the line and tighten it down, and then it's automatically connected to this copper wire via it's just kind of stamped into the copper wiring. And then you just put electrical tape, or we call it magic tape, but it's like a rubberized weatherproofing. And then once it comes out, it will go down to this ground bar where it is then lugged and bolted, and then from there it goes straight down to a halo. See, the tower is also grounded out. So this particular tower had a structural modification done on it, so you could tell because this was the original tower legging, and then they came and welded these steel plates on, which looked to be about 1 inch in thickness, so they're pretty serious. I did that on all 3 legs, and they also gave it this I don't even know what this metal plate. It runs here to here, but on the inside, like here, you can see the original leg, and it's just U-bolted on, and then it runs all the way up the tower. So keeps her sturdy. And then this is what we climb on right here. This is these are called pegs. So they're just enough for me to grab. And then I can put my foot there. And then we hook into this steel cord. It's called a cable grab, or a safety climb. Sorry. Correct name is a safety climb. And we have a little cable grab that rides on with it, so we can go up, but if we fall and go down, it locks so we don't fall. I think it's rated to about 5,000 pounds, so pretty safe there. But so these are the coax cables running up the tower, They're very, very big. These are 1 5/8". More 1 5/8 up there. And then this wiring is for the lighting, which is right here. Just blinks, tells airplanes that it's here. There's a GPS antenna for the shelter. But we'll go in the shelter here and we will take a look about what's going on. So let's go over there. So this is inside the cell shelter. It's pretty loud. We got fans going in here. We'll start from closest here. This is the battery backup unit. So if the AC power fails coming in, the battery backup will pretty much provide power redundantly until the generator has time to kick on. And then if the generator doesn't work, I think these sites are kind of estimated to maybe have about a day, if that, 8 hours to a day on battery power. So each battery is about 200 pounds a piece. They're pretty serious, but very, very heavy too. The voltage coming out of this bank, 24 volt system. So the power comes out of the batteries, runs up these cables, and these cables are cables you would normally see in a locomotive for the DC motors in a locomotive. Runs up the cables and into what we call the power plant. I know all you electrical engineers watching this don't go crazy. They call it a power plant, but the correct terminology is a power rectification system. So in here we have our actual rectifiers. They rectify 24 volts from AC, and then they come out with 2,500 watts. So they're pretty powerful for each little individual one. And then these are converters that step up the voltage from 24 volts to 48 volts at 1,500 watts. Two of those. This site doesn't need that many, that's why most of them are empty, because that's only powering the 700 LTE and then the CDMA cabinet. We'll get into that here in a second. But so basically in here is all the breakers. And these are just fail-safes for something shorts out or pulls too much power. That's all a breaker is, really. So I got different amperages on there. This is all DC. Everything now from the power plant or from the power rectifier system is DC from this point on. So I'll go over every piece of equipment and what it needs. But pretty simple. The bottom here, this right here is negative 48 volts. It's negative 48 because it's a polarity and a safety issue, so they reverse the polarity. And then over here is the DC 24 volts, just normal polarity. And then the rest is normal 24 volts. See that little sticker up there. So, pretty simple. And then if anybody's interested, this is a Emerson Netsure 700. So this is actually the Verizon's LTE cabinet. This site's kind of misleading because this technology right here is actually obsolete. When we're getting ready to shut it down, we're gonna put a different type of equipment. It's still gonna be LTE, but it's gonna be a much more versatile LTE system. So in here, actually on those hard lines we saw out there, or those coax cables we saw on the ice bridge, these are the cables going to it. So you have your alpha sector, beta sector, and your gamma sector. Alpha, if I'm correct, is always pretty much true north, and then beta is, I think it goes in a clockwise equipment. Correct me if I'm wrong, if somebody else is watching this, but so alpha, beta, gamma, that's the 3 sectors on the tower. And then we have transmit, receive, transmit, receive, transmit, receive. So in here is the actual guts of how it works, or what it is. And this is the this is known as the 700 megahertz TRDU. I'm not too sure what that stands for. Usually I know these things, but on this particular case I don't. This is the old school 700 LTE. So if you're on Verizon and you're in Louisiana, you probably have a good chance of being on this machine in the north and south Louisiana areas. I'm actually pretty close to Alexandria right now, but all those transmit and receive lines come down through the top there, and they go into these. So you got transmit, there you go right there, TXRX. So they really do both, but we know them in the trade as transmit and receive individually. One talks, one listens, but they can both do both at the same time. Just depends on what the specific call is and what's easier for the machine. It dictates how much power it needs to put out. So it's all computerized nowadays. This is the fiber optic link that goes from the LTE radio, or we call these RRUs, remote radio units, because they're all monitored remotely. Hence, this is a remote base station. But this is also the 4G equipment. So whenever you're on your phone and you see 4G, if you're on Verizon, this is the kind of stuff you're talking to as of right now. This is what it looks like. Like I said, it will change. This is going to get decommissioned here shortly, within the next several months, and then we're going to come put in the new stuff. But so when you're on 4G, your phone's talking to this. And depending on what section of the tower you're on, you're either on these lines, or these lines. You're north, I think this is like a west almost, and this is more of a southeast bearing. So enough with that. So we follow these over again. The lines come down and they go into these coax cables. So this is the coax cable we saw inside. This is where they put the connector on. This specific connector is called a DIN connector. That's Delta India November, DIN. And then these are lightning arresters. So if the tower gets struck, or the antennas get struck by lightning, the theory is that this actually has a powder charge in it. It's supposed to set it off. Once it sets it off, it fires a projectile through the resonating element in here, and it pretty much completely grounds out the entire system. So then you would have all the power transferred. Instead of coming back into the base station, it would come back down into this ground wire and theoretically out to the halo. So that's what they look like. And these are all your 4G LTE lines currently operating at 700 megahertz. So now we can go to these top lines. These are our 3G equipment. So whenever your phone says 3G or less, you're talking on these ones. This is a really old equipment. Probably going to get deemed decommissioned here within the next couple of years. But on the back side, this is what it looks like. And for anybody out there talking on a flip phone, this is what you're talking on. This specific cabinet happens to be 850 megahertz. A lot of stuff going on in here. A lot of stuff. Not as simple as the LTE cabinet, but it's the exact same framework. Down here, these are our RRUs, or these are our base station radios. So they're a lot smaller, a lot smaller. They're tiny compared to how big those ones were. But once again, like this is our alpha, beta, gamma, and we would call this 2 carriers. If there was 1 carrier of 850 CDMA, we would just see these 3 here. This wouldn't be in here. So we have 2 carriers of 850 megahertz CDMA on this particular cell site. This is our receive, and then up there's the transmit. There we go. So once it comes out of here, the lines go up, they keep going up, they go into these little modules dictate whether they need more power to go up the tower or less power, and they're pretty much talking with this with the RRUs down here. They need to put out more or less. So once we keep going up the line here, we go to our filters, and these are the, I guess for you radio guys out there, these would be your duplexers as well. So they act as duplexers and they're also filters. Okay, so we got our line in up here. This is coming from our monitors down there. Comes into our filter and duplexer. Basically the way this works is this just filters out any unwanted noise in the system. So if these weren't in place, we would probably be getting a very ugly noise from AT&T's equipment, because AT&T has another 850 transmitter that's UMTS. That's AT&T's 3G equipment, UMTS. Universal Mobile Telecommunications Service. And basically, yeah, so this just monitors or filters out noise, keeps the noise out, keeps any unwanted radio frequencies out. So we got different radio stations. These will pretty much take care of that issue. And then from that point on, once they're filtered out and they're good to go, the RF comes out the top parts, I believe, which are these. And from that point on, it then goes to the jumpers back here, which go over and into the hard lines and up about 300 feet to the antenna. And then last comes the last. I think earlier in the TDRU cabinet for the LTEs, you could see fiber optic cables, and there was a couple of Ethernet cables coming from the CDMA cabinet down there as well. That is the internet connection, so to speak, that goes into the LTE router. So the only time we're going to see equipment coming into this is if it's LTE. So once again, trace it out. 4G LTE operating at 700 megahertz. Fiber optics are in this blue conduit. Up the top, over. We got blue pipe coming down. Out of the blue pipe, we got these cables, which are right here. Follow these over, and that leads us to our fiber optic connections. And then we got our, this is the cell site router. So this is just a standard router that gives the cell site an IP address from the provider. This one happens to be a 77505 SAR8, operating at 24 volts positive. And the reason being, all of this equipment is not AC, it's DC. Remember, we trace back here real quick, it's DC because it's all coming from this power plant. That way if the power goes out, we got a battery redundancy there, and keep all this stuff online until the generator kicks in. But that's pretty much it. Pretty much the entire thing about how a cell site works. It's pretty simple once you start reading into it. Really not much to it. There's not much equipment in this room to make it all happen. So With that being said, guys, we'll see you later. And I hope you found this video somewhat informational. So, see y'all later.